All right, welcome back. And so one last thing I want to talk about is a couple of things. When we talk about an iterative process, it means that the next result in the sequence or the next result in the process is based on the previous result in the process. Okay, so we would say we could represent this as a function. So here's our Newton's method, right? So it's a function of x where we have x minus f of x divided by f prime of x. And so this is an iterative process because x of n relies on the function evaluated at the previous approximation. Okay, and so this is why we call it an iterative process. Okay, now there are other iterative processes that we could use. Okay, in fact, there are iterative processes that we can use to find whether we approach a certain number or not. So there's Newton's method is one iterative process for finding zeros or roots of a function or a polynomial. But there are other ones that we could use. For example, we could have this function. So we could let f of x equal 1 over 1/2 x plus 4. Okay, so where this represents an iterative process. So we could say x of n is equal to 1/2 of x of n minus 1 plus 4. Right? And so let's say we have, let's start with x sub 0 equals, what do they want? 0. And then what we want to do is for all, what they're saying is for all n greater than or equal to 1, let x of n equal f of x of n minus 1. So what they're saying is let this represent the iterative process. Okay, so now what we want to do is we want to know, is this approaching a value or not? And so what we want to do is let's do the first, let's say 5 iterations and see if this is approaching a value or not. Okay? And see if we can come up with a conjecture based on any kind of pattern we might see. Okay, so so x0, so what would be x1? So x1 is going to be 1/2 of 0 plus 4, which is going to be 4.5. And then x2 is going to be 1/2 times 4.5 plus 4, which then this is going to be what? 6.25, right? And then if we do x3, it's going to be 1/2 of 6.25 plus 4. Okay? So this is going to be 3.125, right? So 3.125 plus 4, which would be 7.125, right? And so now if I take x4, that's going to equal 1/2 of 7.125 plus 4. Now what's that going to equal? Well, half of that is 3.5, 625. So 3.5. Yeah, 3.5625. Yep. So this is going to be 7.5625. Right? And so let's do it again, one more. So x5 is going to be 1/2 of 7.5625 plus 4. Well, what's that going to be equal to? Well, half of this is what? 3.5, 3.7, 3.78125. Yeah, let me just double check. So it's 3.5. 3.7, 3.5, 3.7, 3.78125. There we go. 7.78215, right? Yep. So based on this, what do you think's going on? Well, it looks like it's heading towards 8. So notice in the beginning, it jumps a lot, right? So the difference between these two is 1.75, right? So it jumps 1.75, and then from here, the jump is less. Right, less than 1. And then here, the jump is even less than that. So the jumps are getting smaller. But it looks like it's heading towards 8. Okay, so my conjecture would be that this is, as n goes towards infinity, right? So as n approaches infinity, the iteration x of n is approaching 8. Okay, and this would be taking a limit. So finding the limit for an iterative process. Okay. Hold on a second. Did I do something wrong? Oh, I sure did. Oh. I can't believe I did that. This is wrong. This is 0. So then this is 4, which means this is 4, which would be 6. And so this would be 6, which would be 7. And then here, this would be 7, which would be 7.5. Is that right? Hold on. Yeah. And then this would be 7.5, which would be 3.725. Hold on, let me just double check that. 3.75. So this would be 7.75. Okay, so that's correct. Sorry, I made a mistake here. Right here, for some reason I multiplied this as if it was a 1, and that messed up everything else. So again, just double check, make sure your answers are correct, and make sure you don't take your time and not make an arithmetic error. But again, the conjecture still stays the same. It looks like it's still approaching 8, because again, you can see how the jump goes from 2, and then the jump is 1, and now the jump is 0.5, and then the jump. So basically, the jump is by half. Okay? So the next jump, it looks like by the pattern, the next jump is only going to be half of 0.25, so it's going to be 0.125. So you're going to add 0.125, and you get 86 865, is that right? Yep. So the jump is 0.25, so half of that is 1.125. Hold on. .25. Yeah, that's right. 0.125, which is 875, is the next one. 7.875. Yeah, that's what's going on. So now you see that pattern too. But anyway, that's another type of iterative process. So you could be given an iterative process to use, and you just have to apply it. Just make sure you pay attention to what you're doing. Have a great day.